for the nth term of a sequence, but, so same as we did before, but before we did for linear, now we're doing for geometric growth or the decay. Again, we're going to have to find our R, okay, or the recurrence relation. And I showed you how to do this yesterday with exercise AE. It's the same principle here. It's exactly the same. There it was already written, but I actually did it for you guys so you can start learning with it. For a recurrence relation, we will still need the starting value and we'll still need our rule. Okay. This works. I'm going to clear this. It does work for investment loans and investments as well. Okay, whether it is compounding or the reducing, it doesn't matter. So it's the same thing. You can see the rule is the same thing, plus because it's compounding, minus because it's reducing, but all the rest is the same, and this is what I showed you anyway. Okay, example 1. I'll move this out the way. Using a rule to find the value of an investment. Okay. The principal value of $10,000 is invested into an account earning compound interest at the rate of 9% per annum. The rule for the value of the investment after n years is given by that. So let's see how we get this. We already know about the 10,000, that's our V0, not a problem. But how did we get this 1.09? Well, exactly like I showed you the other day, $10,000 is how much we're investing, and that is worth 100%. There, plus the interest that they're giving us, which is 9%. So altogether, that is 109%. We can add it all together straight away, which is 1.09 when we get as a decimal. So that's how we get the 1.09. So find the value of the investment after 4 years, correct to the nearest cent. For this one, I'll show you the whole thing. This time when we do V of 1, we're going to get 1.09 to the power of n. You can see this is the rule in terms of n. There's no recurrence relation here. Remember, the recurrence relation is V of n plus 1 equals 1.09 times our Vn. That's a recurrence relation. We have a rule here in terms of n. There is no n plus 1. We see an n and we see an n there. And why is the n as a power? Because every time this is what's going to happen to that rule. It's going to increase by 1.09. I'm saying increase because it's bigger than 1. Okay, if it was less than 1, I'd be saying a decrease. So let me just erase that power of n. It should be to the power of 1. Of course, you don't need to write to the power of 1 times $10,000. So I'm going to get my calculator out and work that one out. But I'm going to do it a simple way, even though I'm going to show you all the steps. I'm just going to go 10,000 and press enter. So store that into my calculator and now go times 1.09. So I do get 10900. So 10,900. After 2 years, it is 1.09 squared times 10,000. Okay, now I'm going to do that one. 1.09 squared times 10 is 11,881. You could do it the old way by pressing enter, as I did, because I stored it into 10,000. You don't have to. This rule already just takes out that year. So it's already doing all that for you. So the next one, V of 3, is a lot easier than using it as a recurrence relation. It's just going to be 1.09 to the power of 3 times 10,000. So I'm just going to work that one out. As I've told you, to the power of 3 times 10,000, I get for V of 3, $12,950.29. And now I'm going to do V of 4. So to the power of 4, of course, 1.09 to the power of 4 times 10,000. I'll write the answer there. And that equals, hopefully I've done all my calculations correct, 14,000. $115.82 when I round it to the nearest cent. That's 82 cents. Okay, just to make sure that they're all with the cents, I'll put 2 zeros here. That's a 0, not a 60, and 2 zeros here. Any questions on part A? Okay, part B. Part B says, find the amount of interest earned after 4 years, correct to the nearest cent. Well, we started off with $10,000. At the end of the 4 years, we have $14,115.82. So the interest that we've earned, I'm just going to take away the 2. So the interest earned after 4 years, the interest, I'll write interest, equals $14,115.82. That's what we have now. We invested $10,000, so take that away. So we have $4,115.82. That's how much interest we earned in the 4 years. Any questions on that one? Okay, I'll just wait a minute and then clear it all. Okay, about to clear it. Part C. Get rid of this. Part C, okay. Part C says find the amount of interest earned in the 4th year. Only in the 4th year, okay? So let's think about how we're going to do this. In the 4th year, the amount of interest earned should be the amount of what we ended up at the end of the 3rd year. We're going to take away from what we've ended up in the 4th year, because that's just the interest that we earned in the 3rd year. So 4th year interest equals end of the 4th year, what we've got in there, minus end of the 3rd year, because we're not adding any money in. So at the end of the 3rd year, if we've got so much money, and then at the end of the 4th year, we've got another $2, that means the interest was $2. So that's what we're going to work out. We've already worked out the end of the 4th year. Let me just check it. It was $14,115.82. We have to work out the end of the 3rd year. So I'm going to use the rule, and I'm just going to do it on the side here, and I'll do it in the green so it doesn't mix in with that. So V of 3, end of the 3rd year is 1.09 to the power of 3 times 10,000. I mean, I could have just written that in there, it wouldn't have mattered. Okay, so 1.09 to the power of 3 times 10,000 is $12,950.29. Okay, so let's take those 2 away. $12,950.29. So this should give us how much interest minus those 2 we made in the 4th year. So $1,165.53 rounded correctly, because it's 0.526 to 53 cents. Any questions on part C? Okay, part D says if the interest compounds monthly, okay, monthly, instead of yearly, write down a rule for the value of the investment after n months. Okay, so we had the 100% and we were adding 9% per annum. So that was per year, that's yearly, per annum means yearly, but we want it monthly. Oh, how many months are there in a year? 12. So we're going to go 100%. You could just write 1. You don't have to keep writing the 100%. 9 divided by 12% per month. Now 9 divided by 12, of course, is 0.75, 3/4. So 0.75. So this is going to be 1 plus 0.75 divided by 100, because 9 divided by 12 is 0.75. Then we got the percentage. So when we work that out, we're going to get 1.0075. Any questions how I got that one? Okay, so let's write our rule. Remember, they just want the rule in terms of n. So we're going to write v of n equals, well, there's the decimal point that we just found, 1.0075. And we're going to put it to the power of n times 10,000. Any questions there? Okay. Part E says use this rule to find the value of the investment after 4 years. That means 48 months. Now this rule here is in terms of months in Part D. So we're just going to use the months. So V, and we're going to find 48 months because this is in months. 1.0075 times 40 to the power of 48, sorry, times 10,000. Okay, let me work that out. 1.0075 to the power of 48. Make sure you press the right arrow if you're doing this, the rest of the times will be in as the power, times 10,000. And I get $14,314.05. Any questions on that one? Okay, I'll give you about 10 seconds to finish writing that. Okay, I'm about to get rid of it unless someone says no. Let's see, you guys. Okay, there we go, clear that. All right, what's up next? Okay, example 2. Example 2 says, a computer system cost $9,500 to buy. There's our original, there's our V of 0. Decreases in value with reducing balance depreciation of 20%. So it's reducing, so decreases, we can see they all mean the same thing. Decreases, reducing balance depreciation. Well, how much is it going down? 20% every year. Recurrence relation that can be used to model the value of the system after n years. Vn is here. Okay, we know this. How do we get the 0.8 again? Well, it's 100%, but it's decreasing, reducing balance depreciation. So minus by how much? 20%. Okay, 100 minus 20% gives us 80%. That as a decimal, 80 divided by 100 is 0.8. That's how we get the 0.8. So there's our recurrence relation. A says, write down the rule for the value of the computer system after n years. Okay, so after n years. So from the recurrence relation, we need to write it in terms of n. Okay, so V of n equals our decimal 0.8, whether we get it from where we worked it out or whether we get it from here, it doesn't really matter. 0.8 to the power of n times our $9,500. Any questions there? Okay. Then part B says use the rule to find the value of the computer system after 8 years. Okay, well this is in years. And we want 8 years. You write your answer correct to the nearest cent. So all we're going to do is substitute n equal to 8. 0.8 to the power of 8 times 9,500. I'll just work that out. 0.8 to the power of 8 right arrow times 9,500. I get $1,593.84 when I round correctly to the nearest cent. Any questions on any of those so far? All right, I'll clear this and move to part C. It says calculate the total depreciation of the computer system. So how much has the computer system gone down? How much gone down? Depreciated in the 8 years. Okay, so the depreciated how much, what it's worth in 8 years, okay, and what we started with, the difference between the two. So we started with, I think it was 9,500. Can someone correct me if I'm wrong? 9,500. Now after 8 years, it's worth only $1,593.84. So how much has it gone down? Let's work this out. 9,500 minus 1,593.84. It's depreciated $7,906.16. Any questions on this one? I mean, I can use the rules with you guys, but really, if you think about what the question's asking, it's very, very logical. Any questions at all? Okay, let's clear this one. Example 3. How many years will it take an investment of $2,000, paying compound interest at 6% per annum, to grow above $3,000? Write your answer to the nearest year. Now this one we're going to use the calculator and the solve function. Okay, so let's think about what's happening here. We want it, we put $2,000 in and we're getting interest, 6% per annum. Okay, so let's work out our decimal. So we've got 100% that we've put in, which is the $2,000. We're going to get 6%. So we're looking at 106%. So our decimal is 1.06 when we divide 106 divided by 100. Okay, beautiful. So let's write down our rule. Our V of n equal 1.06 to the power of n times $2,000. There we go. That's what we've just been doing. Now we want to know when it's above $3,000. So in here, we want this to be 3,000. We're just going to make it equal and then we'll go from there. 1.06 to the power of n times 2,000. To the power of n because we were trying to find how many years. So all we're going to do is go solve on our calculator. You can do it another way, but for those of you who get confused, just go solve and then press enter. So let me do it as well. So menu, calculus, not calculus, sorry, algebra, 1 to solve 3,000 equals 1.06 to the power of n times 2,000. Oops, forgot to hit my right arrow. To the power of n right arrow times 2,000, comma, n. And I get n equals 6.958, etc. Okay, but at exactly 6.958 years, it is equal to $3,000. We want to know how many years it grows above that. So we're going to write n equal 7 years. Okay, no point going down, it has to be more than that. Any questions on example 3? Okay, I'll clear this one. Example 4. Okay, an industry weaving company purchased a new loom. Okay, even if you don't know what a new loom is, it doesn't really matter, but it's a loom. We're talking about weaving company, so it's like a machine that has thread running through, right? Costs $56,000. Has an estimated value of $15,000 after 10 years of operation. So they give us a point like here. The value of the loom is depreciated using a reducing balance method. What is the annual depreciation rate of depreciation? Now this one here, it is best to use the actual formulas. Okay, we're still going to work out our thousands, so our method, so, but we don't know our R. There's our problem. So when we do our 100%, what's this? And it's depreciating, sorry, so it should be a minus. What is that? We don't know what that is, okay? And remember, that's going to be divided by 100 because it's going to be a percentage. So here I'm going to go back and use that original one where it's 1 instead of 100. So I'll put 1 minus R to the power of 100 divided by 100, all to the power of N. We don't know what that is because that's what we do. Remember when we did that 1.09, we wrote it as the power of N. Here we're doing, that's what I'm doing exactly there. I'm subtracting this R, getting that answer and putting it to the power of N. Is there any questions there? Okay, so really our rule for us to write it would be V of N equals 1 minus my R divided by 100 to the power of N times, of course, the original cost $56,000. They tell us that after 10 years, I don't know if I can highlight anything, spotlight, I'll just, after 10 years, it's worth $15,000. So the value after 10 years is 15,000. That's what they tell us. So we're going to use that. V of 10 is 15,000 equals 1 minus R 100 power of N times 56. Okay, and we're going to solve for our, oops, I forgot to put my 10 in there. Oops, let me go back. That's 10. And we're going to solve for our R. Okay, let me have a look. Solve 15,000. Yes, I've got all my answers in. So this, when we do this, it's just going to find our R. Let me do this. So solve menu, algebra, solve 15,000 equal to 1 minus, get my fraction, R divided by 100. Oops, I forgot to put brackets around there. Let me go back and put opening bracket there. Closing bracket here to the power of 10. All right, times 56,000, comma, my R. Okay, press enter. And the answer is, when, what does it give us? It gives us two answers. R equals 12.34 and R equal to 187.6. I'll round it off to 66. Now we're not going to take the 187. Okay, that's just ridiculous. We are going to take the 12.34. Because it says one decimal place, we're going to have R equal to 12.3% per, because it does say annual rate. Any questions on that one? Okay, now I've realised that I have sent you all heaps of emails. They're just the Zoom meetings that I've fixed up. The only problem is I've done all my Zoom meetings on my personal email and not the school email, and that's why we run out of time. So what I might do is send you all again, to remove all those Zoom meetings, log on through my work email, and actually, no, I won't do that. I'll just keep it as it is because I've got them all right now. So you can delete all those Zoom meetings. They should be on your calendar. Just double check that they're on your calendar, Outlook calendar, and we'll just keep them there. It doesn't matter. I'll just keep posting anyway. I'm pretty sure that's it. Let me clear